All right, so today we're going to take a look at section 3.6, and we're going to deal with our last section of truth tables. This is also our last section before your test next week. Do you know when you have a test? It's Wednesday. What are we doing on Monday?
Reviewing.
We're going to review on Monday. Okay. So today we're going to actually take a look at the same idea as the last section did, that is analyzing things as being valid or invalid, but we're going to do it from the perspective of truth tables instead of the perspective of Euler diagrams. Okay? So taking a look first, I want to talk about, there are 4 steps. If you've printed out the notes, you'll see that you have step 1 through 4. It's 4 steps to actually taking an argument that's written out in words, much like the ones from the last section were. Okay? Taking an argument written out in words and actually creating the truth table and evaluating it. So the first item is that whatever statements you have to be turned into symbols. So that each component statement actually has to have a symbol, a P or an S or a T or a Q or whatever the letters are you choose to use. They have to have a letter associated with them. And then step 2 is to express each premise and conclusion symbolically. So maybe you have an and in there, or maybe you have an or maybe you have an arrow statement, right, an if-then statement. So you're sort of putting in all the pieces to turn it into the symbols that combine each of those sentences together. And they may or may not be each individual component sentences. They may actually have some combinations with them. About ready for step 3. Step 3 is kind of a lengthy one. What step 3 does, whoops, hit too many times. Step 3 actually forms the entire argument all at the same time. So, in the last section, what happened was you were given one sentence and a second sentence and then a line, right? This big old bold line, and then it had a conclusion sentence. Do you guys remember that? This right here tells you how to combine all of that into one full-out, long, old statement that you can then evaluate with a truth table. And then step 4 is actually just doing the truth table. And once you do the truth table, what you do is you look at the very last column of your truth table, and if it's all T's, then it means it's a tautology. We encountered that a couple sections ago. And if it's a tautology, it's a valid argument. And if it's not a tautology, it's invalid. All right, so what we're going to do is we're actually going to go out of order. I'm actually going to start with example number 2. But let me talk about this just a little bit more. I know you were writing when I was saying it, but in the last section we had a sentence, a second sentence, we had a line, and then we had a conclusion, right? That was what happened in section 3.5. But what we're going to do, really, is we're going to take sentence number 1, we're going to turn it into symbols. We're going to take sentence number 2, we're going to turn it into symbols, and we're going to take the conclusion sentence and turn it into symbols. So we're going to have things that look an awful lot like number 1 here. So a bunch of symbols, another set of symbols, a line, and some symbols. Okay? What step 3 said we're actually going to do, and we will do it in a minute here, is we're going to join sentence number 1 and sentence number 2. So we're going to move like sentence number 2 up here beside it and put the and symbol in between. And put some big old brackets around it. And then I'm going to put an arrow, and I'm going to put the conclusion at the end. And so when we get done, in the end, it will look something like number 2 looks. So you have a piece, an and statement, a second piece, which would have been the second statement. All of it's inside of these bigger brackets. You have an arrow, and then you have the conclusion statement. Okay? So step number 2, or problem number 2 is actually like they've already done step 1, step 2, step 3 for you. Okay? So let's start here, and I'm going to show you what we do when we've got a big mess like this, so to speak, from the perspective of actually doing a truth table. So you're going to need a lot of space, and this is where like calling the columns numbers is going to come in really handy, because I'm going to run out of space on my screen if I don't. And you may, in fact, on some of these run out of space on your paper if you don't too. but the numbers will give us enough space that we'll probably be able to handle it. So let me do this. All right, so taking a look at what we have here, what are the letters or the different symbols that we have involved in this particular P, Q, and R? So I need a column for P, a column for Q, and a column for R. And notice what we don't have on this one. What don't we have? No tildes. So I don't need any of those on this particular one. All right, so I've got P, Q, and R, and I'll fill in all the trues and falses in a minute. But what do we have next?
P implies Q.
Right, the first set of parentheses, I've got P implies Q, so I need a column for that. Okay, then what? I need a Q implies R. And just to kind of get us in the habit, we really probably won't need it so much on this one, but to get us in the habit, I'm going to call P implies Q number 1 and Q implies R number 2. Then what am I going to do with columns 1 and 2? I'm going to put an and symbol between them. And I eliminate some of my writing by doing that, which is kind of nice. Make sense? Okay. Now what? I need a P implies R, because that's the conclusion statement. And I'm going to call this number 3. Now what?
Now you need 1 and 2.
Right.
Did you make,
I need 1 and 2 imply 3. What do you want to do, Tyler?
like when we're doing our homework, can we make the 1 and 2 number 3?
Sure.
And then make the P implies R number 4?
Yes, you definitely could.
P implies 4.
Yeah, let me change colors so I can show you what Tyler's suggestion was. He said, could I call this 3 and call this 4? And then put 3, arrow 4 over here. And you definitely could do that. Okay. So, and I've been known to do that sometimes too. So, yes, that's another option.
So the numbering, is that really just for our benefit?
Exactly. The numbering is for your benefit. It's absolutely just to save yourself space. That's all it is. All right, so just so that we don't confuse ourselves with so many numbers here, I'm going to erase the pink. So that no, you're fine. Just so that I only have one color going on. All right? Okay, so we've done truth tables somewhat like this before, right? Where we've got lots of column headers and we've got 3 different statements. And if I have 3 statements, I have 8 rows. That's right, Alexis. So what is column P going to have? Right, 4 trues. And then 4 falses. What's column Q going to have? Right, we're going to do them in pairs. True, true, false, false. True, true, false, false. And then column R? Yeah, they're going to alternate. True, false, all the way down. Nicely done. All right, so implications. It's been a couple days since we've talked about these. Actually 4, because we didn't really do any last class since we weren't doing truth tables. Maybe a week. Maybe last Friday since we've done this. All right, so to do an implication statement, when is the arrow, the if-then statements, true? When are conditionals true? Can you give me one of them, Lexus? If false goes to true, or false goes to false. So if any arrow statement, any implication statement starts out false, the result is true. What else?
If it starts out true but ends false, it's
Right.
false.
That one's false. So if it starts out true and ends false, that one's false. And if it starts true and ends true, it's true. Okay, it's good. Everybody's remembering those pieces. Good. All right, so let's take P and Q, and we're going to go in order. The first and second rows match as far as P and Q are concerned. They both start true and end true, which means they are true. Statements 3 and 4, lines 3 and 4, they match. They start true, they end false. So those statements are false. And then the last 4 statements all start out false, which means they're all true. They start false, they are automatically true. All right, the next one is Q implies R. So I've got Q and I've got R. And these are not going to go up in pairs very nicely, but that's not too bad. So we're going to do true implies true, which is, get the right color, true. And the second line is true implies false, which is, that's the false one. Careful. Third line, are you okay, Kaylin?
Yeah, I was looking at the wrong one.
That's okay. All right, so the third line is false implies true, which is true. And then the fourth line is false implies false, which is also true. So lines 3 and 4, rows 3 and 4 are both true. And then, to be honest, the last four are going to match the first four. All right, because the pattern is going to repeat itself. But let's just go through, make sure everybody's on the same page. This is true implies true, which is true. And then true implies false is false. So row 5 is true, row 6 is false. And then rows 7 and 8 both start out false, which means they are true. Awesome. All right, now we're going to join columns 1 and column 2 together. This is an and statement. When is an and statement true?
And both are true.
They're both true. So if we have any false component at all, it's a false statement. All right, so column 1, column 2, I start out true, and what do I get?
True.
True. And then I have a true false.
False.
False true.
False.
False true.
False.
True true.
True.
True false.
False.
True true.
True.
And true true.
True.
All right, all good? Is it easy? All right, we've got the brightest bunch in here today. Which is not to say that everybody else is not bright. That's not what that statement said. Not a valid argument, so don't go saying I said that. All right, column 3. Oh, I've got another arrow statement, so I need to go back and look at my original statements, right? I've got P and R. So here's column P from the beginning. Here's column R right here. So first column and the third column. All right, so the first one is a true implies true, which is true. And then the second one is true implies false. That one's false. The third one is true implies true, so it's
True.
and the fourth one is true implies false, which is false. And then the last four all start out false, so they are true. Well done. And then we're going to look at these last two columns that we have created. And in these last two columns that we have created, we're going to join them together with an if-then statement as well. Right? The first one implies the second one. All right, so this is our last one. True implies true is
True.
false implies false is false implies true.
True.
False implies false. True implies true.
True.
False implies true. That one's true, right? False implies true. And then true implies true for the last two. True. So what do you see at the end here? This is a tautology. And if it's a tautology, you got it. It means it's valid. So please don't make me try to interpret what you think you knew about this but didn't say. Tell me, is it valid or is it invalid? Right? That's why you did all the work, was to make the claim at the end. So make the claim at the end. Say something about it. All right, so kind of a big truth table, right? All right, now we're going to go back to problem number 1. What's the good thing about problem number 1? Say it louder, Tyler.
There's only 2 statements.
There's only 2 statements, which means how many rows am I going to have? 4. So this is a much shorter, much more condensed truth table. That's a good thing. What's the not so good thing?
Yeah.
I've got a tilde. That's true. What else, though? What's different about this one than the second one? The way
It's not a line.
Exactly. Yeah, it's not all on one line right now, right? I've actually got to put the pieces together. So how do we do that? Well, to put the pieces together, we take the first.
This is all in big brackets.
It will be in a minute, yeah. So we take our first statement. What happens? How do we join it with the second one? And, exactly. So this is an and statement with the second component, the second line of the argument. And then Tyler said, and this is correct at this point, we'll put it in a big bracket. Then I need an error and implies tilde Q. Perfect. Okay, so you've got to be able to stick that all together. Yes?
So the borderline is pretty much then.
Yes, that line at the bottom is making the word then or the word therefore or something like that. Yes. Yeah, and that's a good way to think about it, because if you're talking about the first two pieces joined together, the word if, then the line would be after that would be the word then. Mm-hmm. Do you have a question, Tyler?
What if it's like some of the unit diagrams we did that had 3 statements above the line?
I don't think there's any like that in this section. I think they've only got 2 statements.
Okay.
Some of them look messy. The one we do in a minute is going to look a little bit messy, but still going to be 2 statements. I don't think you're going to see anything with 3. All right, so taking a look at this, I'm going to start a truth table. What's going to be in my truth table first? P, Q. Yes, and you actually have a choice in the matter. You can put the tilde P and tilde Q in automatically, or you could save the tilde Q till the end because you don't actually need it till the end, and it's just its location might be a little bit more convenient if we wait. Are we okay with that? Because otherwise then I'm going to be drawing arrows that go backwards to do if-then statements. It's going to look a little bit messy. So I think let's wait on the tilde Q, but let's do the tilde P next. If you do the tilde Q now, it would be fine. It's just going to be a little bit messier to think about, that's all. All right, so I've got tilde P. If I ignore the tilde Q, what would I do next?
Write what's in parentheses.
Right, I'm going to write what's in that one set of parentheses that I have, which is, try it again, tilde P, arrow Q, right? And because I like numbers, it's one of those things about being a math person, I'm going to call this number 1. So here's column 1. Now what? Yeah, let's do 1 and P, right? So now that's everything inside of my brackets. Now what? Yeah, so now I need the tilde Q. I mean, at the point where I have to have it, so if you haven't already put it in, you need it now. If you've already put it in, then you've already got it. But if you haven't, now you need it. So let's do what Tyler suggested earlier. Let's actually call 1 and P 2 and call tilde Q 3. And then what would we have? 2 implies 3. And again, there's other ways you could write that, but this would work. All right, what's going to go underneath P? True, true, false, false, because there's only 4 rows because there's only 2 statements. What goes under Q? True, false, true, false. How about tilde P? False, false, true, true. All right, so those are the ones that are the most straightforward. After that, we end up with implications, and the first implication is going backwards. I've got to start with tilde P and go backwards to Q, which means I'm doing this, right? So I'm starting out false to true. That's true. The second one is false to false, which is true. The third one is true to true. That's true. The fourth one is true to false. That's false. Then I'm going to take the statement that I just created, and I'm going to join it with column P, which is back at the beginning, with an and symbol, right? Okay. So again, now when we're doing and symbol, it doesn't matter which order I look at them in. There is no order that matters. I just look at the 2 symbols, right? So here's a true and a true, which is true. And then a true and a true is true. And then the second 2 both start out false. They end up in true and falses, but they've got a false in them, so they're false. Anytime you have a false statement inside of an and statement, the entire result is false. Okay? Tilde Q, we haven't done that yet, so what would tilde Q be? False, true, false, true. And again, the reason I chose to do this one at the end is because now I actually need it. I can take column 2 and column 3, and I can draw my arrow in this order. Okay, hang on. There we go. 2 implies 3. So the first one is true implies false, which is false. Second one's true implies true. Third one, false implies false. And the last one, false implies true. So what can we say?
Invalid.
Invalid. Why?
Because it's not in the column.
Exactly. This one is invalid. Now we're going to put it all together. There's a couple typos. I've left them in because they're already on your paper as typos, I believe. This says, if I were a woman, it should say, if I were your woman. Not a. And then at the bottom it should say also not your woman. Otherwise it just doesn't make a lot of sense. It's a little funny statement anyway. Okay. It says, if I were your woman and you were my man, then I'd never stop loving you. I've stopped loving you. Therefore, I'm not your woman or you're not my man. Ouch, man, that's harsh, isn't it? All right, so the first thing we've got to do is what? I need to assign some letters, right? I can't do anything in the truth table. Nothing can follow through with this. And I don't know about you, but even the idea of doing a Euler diagram with this one does not look good, right? I mean, those Euler diagrams were useful in some cases, but it does not look so useful for this because there's a lot going on here. So, yeah, I need some symbols. So let's see. We're going to take this slide, and we're first going to identify some symbols. So P, Q, and R, I do have 3 different things going on here. What would symbol P be in this situation? What would it be? I thought something about being a woman, right? I am your woman. So let's let P be I am your woman. What about statement Q? You are my man. You guys are chuckling a little bit even as we write these down, aren't you? How about the last one?
Never stop loving you.
All right, so how about I will or did or do, or I don't care what verb you use, but I will never stop loving you. I would love you forever. I will like you for always. That's a different book. Okay, so it says, if I were your woman and you were my man. Okay, I'm going to pause at the comma. What did it tell me to do so far? I need an and that joins what? P and Q. So what I'm going to do here is I'm going to take the P and I'm going to take the Q and I'm going to join in with an and. So I'm working on like statement number 1, if you will. But I'm not done with statement number 1 because then it says, then I'd never stop loving you. Right? That's still in the same sentence. All right, so I'm going to put these both in parentheses and then the arrow to do the implies. And what does it imply? Are. What does statement 2 say? It's short and sweet. I've stopped loving you, which would be what? That's tilde R. Lo and behold, things didn't work out. Then, so there's my conclusion statement. What does it say after that? All right, I'm not your woman, so it's tilde P, and then what? Or tilde Q. Okay, so that's step 2 that we just did. Step 1 was assigning the letters, and you need to write them down. Don't make me guess what P, Q, and R are in your statements, because I'm probably not going to guess what you thought you meant to say. All right? Step number 1, assigning the letters. Step number 2 is writing this sort of a structure down. And while you could write the structure in the one-line, conglomerate mess to start with, that would be okay. This is probably easier to start with, and then to join them all together in the one line. Okay? So if I join them all together in the one line, what do I do?
Brackets.
All right, I'm going to need brackets. And what am I going to need brackets around, Kaylin?
Your first set of parentheses.
All right, so I'm going to start with my first set of parentheses. Or, you know what, let me say it this way. My first line. How about line number 1? I'm going to write P and Q, arrow, R, and I'm going to put that inside of brackets. What do I have to do with that set of brackets? So that's everything that was on line 1. What do I do next? How am I going to join it with tilde R? Say it louder, Alexis. With the word and. So the word and looks like that as a symbol, right? So line number 1 and line number 2, which is tilde R. So join statement 1 and statement 2 with the word and. Now I'm sort of running out of symbols because I need another set of symbols that groups all of this together, and luckily for us, we do have one more. We got some curly braces. If you want to use parentheses again, you can, but some other kind of, some other symbol that joins all of this together with what next? Implies the conclusion, and the conclusion is tilde P or tilde Q, and I'm going to put parentheses around that conclusion. And we're going to see how well I can do fitting this all on the next screen, because my last time I did it, I ran out of space. Let me see if I can do better this time. All right, are you guys ready? Yes, this is yes. All right, let's take a look at this. This is a gigantic truth table. I need to give myself a little more space at the top.
This is one of those numbers.
Yeah, if I don't have numbers, I'm not going to even stand a shot here. So I need some columns here at the beginning that represent what? All right, I need a P, Q, and R, and you can already tell how skinny my columns are by comparison, right? All right, after I've got P, Q, and R, now what? I do need tildes. I don't actually need them right away, so I could wait. And since I don't need them right away, I think I will. If you want to put them in now, it wouldn't hurt anything, but I'm just going to wait for a minute. What else could I do instead of the tildes next? Yeah, that first set of parentheses, which joins P and Q, right? So here's P and Q, and just for fun, we're going to call that 1. One of many. Yeah. All right, after I've got that, what do I need now? So I took care of the parenthesis. 1 implies R would be a good statement next. So I've got 1 implies R. Would you like to give that a number? All right, we'll call it 2. Okay. What next? Okay, so if I'm going to do 2 and tilde R, I need tilde R. I didn't do it yet, so I have to do it now. If you did it, or if you already did it, you're awesome, and you don't have to do it now because you already did it. But I didn't, so I need a tilde R, and I didn't have it. So that now I have it. So now what do I want now that I have my tilde R? 2 and tilde R. You want to give that a number? 3. All right, how are we doing? Oh, we have everything in the curly braces now, don't we? Okay, now what? I need a tilde P and a tilde Q because, like I said, I didn't do them already. If you did, you've already got them. But I need a tilde P, and I'm going to need a tilde Q. Perfect. Now what? Tilde P or tilde Q. Can I give it a number? 63 might be overdoing it just a tad. How about 4? Will that work? Okay, now what? I think that we're ready to do it, aren't we? I think we've got everything, and so everything together is going to look like what? Yeah, it's the last time I did a number, which was 3 implies 4. You have no idea how much more space I have than when I did this yesterday. This is awesome. Did you? It did bring me to the edge, but I had enough room to write 3 and 4. Last time all I had enough room was to barely squeeze in the number 3. So, all right, what's P going to say? 4 trues, 4 falses. Then what? True, true, false, false in pairs. And then? Alternate. True, false, true, false. Lovely. P and Q. First 2 columns join with the word and means what has to be true for them to be true? They both have to be true, which is lines 1 and 2, right? So the first 2 are true, and then the last 6 are all false. All right, so I'm actually going to take this column now, and I'm going to go backwards to column R with an arrow statement, correct? All right, so this is an implication. The first one says true implies true, which is true. The second one, true implies false. False. And then the last 6 are all starting out false, which means they're true. Tilde R. You guys are good at tildes. Tell me what tilde R is going to say. Opposite of R. False, true. Whoops. Put the right one in there. False, true. All the way down. And then I'm going to join the last two columns that I did, column that I labeled column 2 and the column that I created tilde r, and I'm joining them with the word and. So I need them both to be true in order to write a true work down, right? So the first one says true, false, which is second one false, true. Third one true, false. Fourth one true, true. Finally got a true. And then I've got true, false, true, 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 false, and true, true. Lovely. Tilde P. What do we have? 4 falses. And then 4 trues. And then column tilde Q. Good. False, false, true, true. False, false, true, true. We're almost done, folks. How about an or statement? We haven't done an or statement today, so we should definitely do one. When is an or statement true? Good. At least one of them's true. So either one of them's true or both of them are true. So I'm going to look at the last two columns, tilde Q and tilde P, and I'm joining them with or. So the first one says false, false, which is false. And then I have another false, false. False, true. False, true. True. True, false. True, false. True, true. True, true. Last column, 3 implies 4. So change colors. Here's 3. Here's 4. I'm starting with 3. I'm going to 4. So false implies false is false implies false. False implies true. True implies true. False implies true. True implies true. False implies true. True implies true. And what do you see? It's valid because this is a tautology. So the argument, as funny as it sounded and as sad as it was for whoever that young man was a valid argument. All right, last thing. And this is by far the easiest portion of this because it's the quickest. How's that? There was a chorus of yays. All right, so I'm going to try and squeeze this in the next 3 minutes. We'll see. There are 4 different forms that are valid argument forms that we're going to look at. Then there are 2 different forms that are invalid or fallacies. Okay? So the first one says if you have P implies Q and you know that P is true, then necessarily Q must also be true. And this was my argument where I said if I'm a mom, then I'm a woman. And so if I tell you that the person standing out in the hallway is a mom, then you know for sure they're a woman. Okay? Modus tollens says if I have P implies Q and then I know that the result is tilde Q, then I know tilde P. And this is equivalent to my argument when I had it and I said if I'm a mom, then I'm a woman, and I tell you that the person out in the hall is not a woman, then you know for sure she's not a mom. Well, he's not a mom, right? Yeah. All right, disjunctive syllogism says the following. If you have P and Q, and actually the order could be switched. It could say P and Q or Q and P. And you know one of them is false, that is, you know one of them is the opposite, then it must be that the other one, whichever it is, follows. Right? If I say I teach math and I'm a woman, and I tell you I don't teach math, then you know I am a woman. I mean, the other one has to be true. And then reasoning by transitivity says that if you have P implies Q and Q implies R, then necessarily P implies R. And you see this in math all the time when you say something like, if 1 is less than 2 and 2 is less than 3, then automatically 1 is less than 3. If A equals B and B equals C, then A equals C. Okay, this is reasoning by transitivity. The other 2 are fallacies, and they look an awful lot like the first 2 that are valid. They say if you know P implies Q and you know Q, then you know P. That's not exactly what the first one said, but it looks really similar. Again, this one says if I know, if I have the statement, if I'm a mom, then I'm a woman, and I tell you I'm a woman, then I'm a mom. Maybe not. That's not valid, right? I mean, that doesn't have to be true. And the inverse is similar. This one says P implies Q, And if I know that tilde P, then I know tilde Q. Again, if I'm a mom, then I'm a woman. I tell you I'm not a woman. I'm sorry, I said it wrong. I am not a mom. Then you still don't know if I'm a woman, just based on that alone. So the argument would not be valid. Let me tell you in 1 minute how you do these, and then I will finish this and post it online so you can hear the rest of it, okay? The goal is to take the sentences, just like we did on the one about that you are my woman, I'm your man business, and to create the symbols. And then all you have to do is match the symbols with one of those 6 forms. It will match one of them. Once you know which one it matches, you know if it's valid or invalid. That's all you have to do for these. Turn them into symbols and match them. It's like matching when you're a little kid and you play the memory game. It's like that. Okay? So I'm going to pause this and I will... All right, so to finish up this last section, what we're going to do is we're going to actually turn each of these into symbols. And then we're going to compare them back to the original ones that we were looking at and see which one it matches. So for starters on this one, it says, if Kerry Wood pitches, then the Cubs win. So we can start out with letting the Kerry Wood pitches part be P. In fact, let me use a different color for that. Let's do P. And then since it's an if then, we've got the arrow for the implication statement. And then the Q can be that the Cubs win. Then it tells us the Cubs do not win, which would be tilde Q. And then we've got this arrow, this line, and the statement then at the bottom says Kerry Woods does not pitch, which would be tilde P. So if we're taking a look at P implies Q, and then tilde Q, and then tilde P, and we flip back over here, that actually matches exactly with the valid arguments form for modus tollens, which is a valid argument form, meaning that this is valid. Part of the question said decide if the argument's valid or a fallacy. Then it says give the form that applies. So the giving the form that would apply would say that this is, we know this by modus tollens. So no truth tables, no Euler diagrams, you're simply matching. This is valid by modus tollens. Now, in honor of my mother-in-law, wonderful woman, has lots of shoes, we've got number 5. Number 5 says, if she buys another pair of shoes, her closet will overflow. Her closet will overflow, therefore, she buys, or maybe bought, another pair of shoes. So the first line says, if she buys another pair of shoes, so that can be P. P, that is, she buys another pair of shoes. If then, so I've got an arrow. It says her closet will overflow. All right, so that can be Q. Then it says her closet will, did, would, is, going to, whatever, overflow. So that would be Q again. Therefore, and then it says she buys, bought, whatever, another pair of shoes, which was P. So this says P implies Q, and then Q, therefore P. And if we're matching that up, that actually matches up exactly to fallacy of the converse. So this is a fallacy, or it is invalid by fallacy of the converse. Right? Because in theory, what we're saying on this particular one is the closet overflows, but maybe it wasn't because she bought another pair of shoes. Maybe she bought, 2 more coats or something like that, and now the closet's overflowing. And that's actually what you're seeing happen here when you're doing the fallacy of the converse.